Let's see now what are some of the challenges with relational databases. We are going to use a simple diagram. On one axis, we are going to show the volume of data that we are trying to process. And on the other axis, cost of our database and the equipment. If we look at the cost of our equipment, the storage space and the processors, we see that we can achieve a fairly linear cost. If we need 2 times more space, we need to pay 2 times more. When it comes to CPUs and processing power, we don't get much faster CPUs than before, but we can get them in larger numbers. So multiprocessors and multi-core systems are becoming the norm. Now, if we put in this perspective the cost of our relational database systems, we will be surprised that the cost does not behave in such a linear fashion. So we see that when you start with relational database, your cost is low. You may start with some open source, small database. Later you graduate to some of the more commercial systems. Eventually you end up with fairly large systems, and then they are going to be very, very expensive. And there are 2 problems here. One problem is that the processing is relatively slow. The more data we have, the relational databases are going to become slower and slower. And then for large volumes of data, we are going to pay a really high price in order to be able to have relational databases that can handle those. Not only that, but when you're dealing with truly large volumes, you are going to have problems that relational databases cannot handle them. And that was actually one of the motivations that we have seen in the companies that started processing data on the web scale. Companies like Google and Yahoo, they have figured out that relational databases simply cannot store the data that they would like to deal with. What we would like to do is to find a solution, find a technology that would be able to take the cost of the relational database and flatten it, make it behave more like the cost of our storage and our processors. So we would like to avoid the exponential cost of such systems. We would like to have a linear dependency. And the other issue that we would like to address is that we would like to be able to handle data that cannot be handled with relational database systems. So there are 2 factors. One is improving the performance, reducing the cost. And the second issue we would like to address is to enable us to deal with data that the relational databases cannot handle. Now, this is where the categories of systems like big data systems, Hadoop, variety of NoSQL systems come into play. They are trying to address different aspects of these problems and enable us to have the processing of larger volumes of data much faster than we do that today with relational databases. You will see that there is no silver bullet. We are going to explore several different technologies. Each of these technologies is going to have its sweet spot. Some of the technologies, like Hadoop, is going to focus on handling this largest volume of data. Some of the technologies are going to focus on processing of data in real time, handling streams of data that are arriving into our systems. Some others are going to focus on representing data, which format may vary, and where you cannot find a schema that you can subscribe from the very beginning. Some other systems are going to focus on storing information as graphs with large number of nodes that are connected with each other. In the rest of the course, we are going to explore these approaches, and you will learn how to find the system that will be the best match for your application.